little follow-up video. Speaking about the 338 Edge, my previous video I talked about some pros and cons in owning one. I'm going to go a little more in depth in dealing with dies. So, in that video I told you that I had my ultra micrometer seeder. I ordered it in 300 rem ultra mag, and they just opened it up to accept a 338 bullet. That's going to be your easiest way to get a die. Redding will do it. Almost anybody will do custom dies. I just prefer the Redding or the Forster style, and the Forsters are cheaper. And I have a Forster coax. Also, the Forsters are a little shorter because I have the coax. The actual press arm goes over this, and the Forster dies will clear, whereas the Hornadays will not clear, and sometimes the Reddings are iffy if they'll clear. So I've already adjusted the overall length. And what you're doing when you do that, real quick, is you're adjusting how far in and out your bullet is seated into the case. So as it's in the chamber, the bullet is, you're changing the difference from the ogive of the bullet and its engagement to the lands. Most people do like between 10 and 20, and some people go up to 40 thousandths jump. What that means is that's how far the bullet will travel out of the case before it engages the rifling. I do between 15 and 20. Some people do as much as 40. I think that's crazy, but to each their own, right? So I've already adjusted that using what I think is the best method that doesn't require any tools other than some knowledge, a punch, and a rubber mallet. So off camera I've adjusted this die already, and I'll link to a video describing the method I use, and you'll see how I use a similar method to adjust my die for bumping the shoulder. So I have a PTG one piece bolt. This method will work anyways. So I've stripped the bolt down. I've taken my firing pin out. I've taken my extractor and my, I want to say, what is it, plunger. I've taken that out, and I just used like I said, a rubber mallet and a small punch. As far as taking the firing pin out, there's all kinds of tools on the market to do it. What I do is I just use a penny. So I just leverage that up, and then it twists off. One of these days I am going to buy the tool, because using a penny sucks. It takes a couple tries and it hurts your fingers, and the tool is just way quicker. You also need a cleaning rod. I have a cleaning rod and the muzzle of the bore of the rifle, and that's just for knocking the cases out after you check for size. So what I have here is my full-length sizing die. It's an S bushing type from Redding. It's for a 300 rum. So a 338 Edge, in my case, is literally a 300 rum necked up to accept a 338 caliber bullet. So 300 rum dies are generally going to be your starting point for this. In my case, when I ordered the rifle, the gunsmith reamed out the die to accept the larger neck bushings for 338 caliber bullets. So that's what I have here. So I just have a normal Redding bushing full length sizer die that's been reamed out to accept the 338 caliber bushings. I have removed the expander mandrel and the little pin that pops out the firing pin. I've removed that just because these things, you know, they break all the time, so I always keep a supply on hand. But I'm not using it right now, so there's no reason for it to be in the die, so I removed it. And actually, I think I've primed this case. Yeah, this case is primed. I'm using, so I have a Redding die. I use a Forster coax. And if you're not familiar with a coax, the die can float on this axis, and the case is allowed to float on this axis. So when they push them together, they find their own center, like so, as opposed to a normal C-type press where the die in the bullet are both held rigidly, and you're depending on the accuracy of the press. And so to that point, I prefer the Hornady lock rings because they allow a little more float than the Forster ones, but it's not a big deal. So I have my die, my press, my empty case, and you're going to need whatever Allen wrench it takes to loosen your die. I'm going to find it now. Probably just use my Harbor Freight little multi-Allen wrench thing here. Okay. So what you want to do is loosen this until you can you can turn it, but it's kind of stiff. So what you're going to do, probably be easier to show you like this. So you'll notice with the bolt completely stripped, if I close it and let go of the handle, it just drops. So that's what you're looking to see. So I'm going to put my case in. I'm going to try and close the bolt. See how it doesn't drop? That means the shoulder of that case is too far forward. So it's actually, the case is actually slightly bigger than the chamber. It's actually pretty tight to close. This is pretty common with Bertram brass. And really, we're probably only talking about a couple thousands. So I had this set up for, I don't know why, I forget how I had this set up. I think I had it set up for using rum brass, and the Bertram's a little thicker, so you have to bump the shoulder more. Anyways, what you're trying to achieve is you want the shoulder of your case to be about 2/1000 shorter than the actual true headspace. So that gives it enough room to expand, but it won't expand too much that it'll prematurely work hard in the brass. That's what we're trying to accomplish here. So I'll show you how we're going to do that. So what I'm going to do, and I'm going to use my phone to show you at the actual press, it's I only have one GoPro, is I'm going to slowly adjust this die down. So I'll adjust it down maybe an 1/8 turn, size it, check it again, and I'll keep doing that until the bolt drops free. And then you know your shoulder is between 1 and 2/1000 short of the true headspace. Over here at the press, I've got my case in. I'm going to adjust my die so it goes maybe, I don't know, what is that, a 1/4 turn? So basically adjusting the die so it's further down like that. I'm going to use some unique case lube. I'm going to size it. I felt that it definitely pushed the shoulder back a little bit, maybe not much. I'm going to go back over here and we're going to test it. I'm just going to make sure my cleaning rod's out of the way. Just going to push the bolt forward, let it drop. Oh, see? Drops almost on the first attempt. We got it sized right. So what I want to do now, actually wasn't expecting that to work on the first try. So what I'm going to do now, move it up. So we're going to back this out just a smidge. See if you can see that. There we go. size. See, the bolt just drops free like that. So we're good. All right, let me switch cameras so you get a stable view. Hopefully it's going to show up. So it looks like, can you see that? So it looks like we're reading 4, 4, 6, 7, almost 8. So we do the one we just on our adjusted die. Reading at exactly 65, maybe a skosh over. So we literally just bumped the shoulder back 2 thousandths, and then I'll show you. Goes. There it is. So that little adjustment is all it took. Probably not even an eighth of a turn, maybe a 60th of a turn on that die. We bumped our shoulder back 2 thousandths of an inch, maybe 2 thousandths and a couple tenths. So now we've given our case the perfect amount of resizing. So we're not overworking the case. So we're not resizing it too small and letting it expand too big. So we're going to get our best brass life out of this. So here's our loaded round. So both the full length sizing and the seating die have been adjusted. There you have it. You see how the first time there was a tiny little bit of hesitation? I think that was actually just friction from the bolt face working on the case head. That's what you want. You want that bolt to drop down nice and easy on its own, just like that. So that means your brass has enough room to expand and your bullet's not jammed up into your rifling. Now the trick to this is you have to start out with oversized tolerances, I guess you would say. So your brass has to be a little big and your seating depth has to be a little long. It's just a tedious process because you have to adjust a tiny bit test, a tiny bit test, a tiny bit test. In fact, like, I'm actually a little disappointed that I got it almost exactly right on the first attempt on the on setting the shoulder bump, because I really wanted to show you like having to test it like a bajillion times. But what are you gonna do? What I should have done is recorded me doing the changing the bullet seating, because that probably took me about 15 attempts. And I started out, so I checked that gap like I talked about, and I started out adjusting by about 15 thousandths a couple times, and then I went to 10, and then 5, and then, you know, once I knew I was really close, like the bolt would drop like down to there, but not quite seat, but I could still seat it with one finger. And then I started adjusting it by 1,000, so after about 7 times of that, it just dropped free. And then I wrote down the settings on my die, so we'll just take a look at that real quick. So hopefully you're seeing that. So you have a graduated scale here, and then 0 through 25. Each one of these ticks is 1,000ths. So you have a 0 and 1, 2, and then 1, 2. I think it goes up to 4. So I just wrote down plus 2, 7. So I'll take the 0 all the way up to 2, and then I'll go up 7 graduations, and I know that that is my 0, and then I can adjust from there. And since we've adjusted our screw here to be snug, we don't have to worry about losing our adjustment, so we can kind of hold on to it, torque it back down, and then this die will be set up. So that's just an example of the sort of things you kind of have to, I don't know if deal with it's the right word, but you have to take into account when dealing with a Wildcat. And as far as Wildcats go, this is a pretty easy one. Because again, someone just took a 300 rum and necked it up to 338, which... So there you have it. We're using 300 rum dies to make our 338 edge work. This is a real quick video, just sort of explaining how that process works. I'm going to go ahead and size the rest of the cases, make sure they fit right, and then I'll get ready to start loading up for my load development. Real quick little addendum here. So here's a bullet that I seated using the same settings as a 300 Burger, with a different die though. But I just want you to see how this isn't going to want to, the bolt isn't going to close. So what's happening here, as these bolt lugs are trying to cam forward onto the bolt lug faces inside the action, it's actually shoving the bullet into the lands and grooves of the rifling. That's why it's not closing. So if you're doing this method, and I'll link to a video that describes it, does give you a tip here if you're doing this method. If you see the surface of your action here and the surface of your bolt handle, you can kind of use this as a gauge for how much further you need to go. Like that's probably 20 or 30 thousandths. So as you're, here, let me pull this out. See that you have that gap there? That'll help you gauge it. So as you're seating the bullet further down, that gap will close and close and close until eventually excuse me, the extractor's not in the bolt, so it's obviously not extracting. See how that gap goes to 0 or maybe a thousandths? So that's sort of a way you kind of gauge you're getting close. I would set up your brass first, because I actually had a problem with that. I kept adjusting the bullet down, and the bolt would never close on it until the bullet was, you know, sticking out that far, and I knew something was wrong. So I pulled the bullet, and then I tried to adjust the brass, and I realized that I needed to size the brass more. So I would adjust your brass headspace, and then adjust your seating depth. For match type bullets like this, I would say probably 20 to 25 thousandths in my opinions as far out from the land you want to go. You don't want a crazy amount of jump, right? You want, so let's, I'll make a second part to this video using my headset. We'll talk about bullet jump probably as part of load development. Anyways, the point is you don't want this bullet traveling an excessive amount of time before it's engaging the lands and grooves, right? Because what happens is this neck expands and the bullet moves forward, and if you have too much of a jump, the bullet actually spends time unsupported by anything, so it can go into the lands at some weird angle, you know, which will affect accuracy. You need a little jump so you don't get an immediate pressure spike. So if you fire it and the bullet's sitting there touching the landing grooves, it's already it doesn't get a head start to jump into the rifling. So it's going to take more gas pressure to keep that bullet moving, I guess. So you'll get a bigger gas spike, and you'll get like real early pressure signs.